Next. Yeah, based on we previously collected from the working doc, today we have two agenda items. One is for the regular SIG update and review. In the previous meeting, we already reviewed two SIGs. One is scalability SIG. The other one is edge SIG. In total, we have four SIGs. For today's meeting, we are going to review the network SIG. Vinay is leading the network SIG work. So today he is going to present the plan and the high-level architecture and the next important work items for this SIG, just to give us an overview, update, and also to see if there are any suggestions or feedbacks or guides for networking SIG's work. For people that are not familiar with the network SIG, it's mostly about the MISA project. Remember in Centaurus, we have Arctos and MISA. Networking SIG is mostly about MISA. And also, Deepak has a proposal to add one more member into our advisory board, Professor Hankem Weatherspoon. Deepak, I remember this is also the CEO of the how to pronounce it? Yeah. Okay.
Yeah.
Okay, these are the two pre-registered topics. Besides this, does anybody have anything else want to discuss at today's meeting? If not, we can just do these two items. Because I think the second item most likely will take a much shorter time. So if you guys don't mind, I suggest we switch the order. We first do the Deepak's item, then we can have all the remaining time for Vinay, so we have more time to have any detailed discussions.
Yeah, we can do that.
Okay. So Deepak, how about you start?
Yeah, let me just share my screen. I just want to show the, yeah. Okay, one second. Yeah, I would like to propose adding Professor Hakeem Weatherspoon to our advisory committee. So Professor Hakeem is a professor at Cornell, and we've been kind of doing collaboration work with him in a couple of projects actually. And he's a professor, and he's the CEO of a company called Exotanium as well. Exotanium, these guys, they do cloud optimization, and they have a new next generation containerization technology as well. So it's very visible in the cloud community and the research community as well. So it'll be great to have him on board as part of our SIG TSC board as an advisor. So obviously he's pretty busy, so he's not going to be able to make all the meetings. So whenever he can, he can provide us his thoughts and maybe guidance, as part of the TSC.
I think it's a good idea. His records look credible and seems like a really cool person to have on the team.
Yeah, I can flash his website as well, Exotanium, just quickly. I mean, yes, but yeah, it'll be great to have him on board. 1 second. Yeah. Okay. Yeah, there you go. That's their company as well. So this is all professors, and the students, the PhDs and postdocs. They started a startup funded, actually spawned by Cornell itself. Anyway, that's it. So yeah, we can do the vote, Shawnee.
Yeah, do we still have a collaboration with them? I mean,
no, we don't. No.
Okay. And for the advisory board, we already have 2 members, including this one, Professor Hankem. We will have 3 members. Do we have any plans to have like a regular consulting with them? Just wondering.
Well, yeah, we can do that. I mean, so we can bring it up with them. So just bring them, maybe do one meeting. In one of the meetings, we can ask the advisors to come and share their thoughts, at least, come and introduce themselves. And yeah, we can do that.
Yeah, I understand that they are very busy. They want to be able to attend all TSC meetings, but we probably can like quarterly or something, or sometime having some regular thing. Just some thoughts, random thoughts.
No, that's a good idea. Yeah, definitely. At least because we, Dr. Shang is obviously on the call.
Yeah, Dr. Shang is okay. Yeah.
But the Chris and Professor Hakeem, if he gets voted, then we can ask them to kind of come at least, and initially introduce themselves. Yeah.
Moni, can you help initiate a vote? Let me first count how many TSC members we have in this meeting to ensure we meet the quorum. Deepak, Stefan, Prisha, Nikita. Yeah, definitely we have enough members.
Deepak, one more suggestion. Normally, like I would suggest that have a plan for like bringing this advisory board in which area and what exactly we are trying to achieve on this one. I mean, I'll see Professor Hakim's credentials are extremely good, but we would like to see that how this correlate to our project area.
Exactly. I think we plan to make a plan.
I can talk about that actually. So essentially, these guys they're working with a lot of customers. So the whole cloud optimization work they're doing and the whole containerization work. So I think it'll be good. As they, so maybe potential opportunity to kind of bring in their customer base and see if Centaurus makes them sense for them, so from that perspective. So yeah.
I think also for periodically, maybe we can host like advisory board roundtable, use one of our meetings and down the road, and then they can also talk about, what they think about our project, give us advice. I mean, so far we also have a Chris Anichek from Linux Foundation, Dr. Sean, and this professor, right? So, and also I recommend we should document that on our website,
Yes.
A list of advice.
Yeah, because that's a good idea. Yeah, I think if we have advisory board, we should kind of think about how they benefit us, right? How we have some regular mechanism to work together. We can work on the detail later.
Yeah. Do you want to actually put together something, Shawning, on the idea that how we would like to sort of like help with the advisory board? It should not be a namesake thing. I would like to really, I mean, as a TSC member, I would demand like there is some level of clarity on the whole thing. Because we can, I mean, I have 20 other people I can bring to this meeting who are credibly valuable to the community and could be. But if there is a clear-cut value, then it makes much more sense to bring them on advisory board.
Yeah.
I mean, Deepak, I know you definitely have a plan. You are well connected with Professor Hakeem, and if he is in UC Berkeley and UW, then definitely he has a great credential for sure.
But not you, he's Cornell,
Yeah.
He did his PhD from Berkeley, but he is a professor at Cornell. But I think that's a good point, though. So we should articulate that, what advisory board is, and and then we should do a kickoff meeting as well. Maybe one session, one TSC session, just dedicated to the advisor. Let them talk.
Yep.
Yeah.
Just to add some color to that, if I may, Professor Hakeem and the Exotenium company, the collaboration that we worked with them in the past, one of the things that we found intriguing, their technology called X containers, which essentially tries to minimize the kernel overhead, the context switching overhead, and it speeds up your secure containers. So that we feel is pretty helpful for the Octos side of
Centaurus. It's next generation of containerization, unikernel based, library OS based container, much more lightweight. And the other thing I wanted to highlight that it's one of the things they're done, and one of the collaboration we did was a thing called a technology called Zen Blanket. So essentially, they have they're doing pretty good actually with the companies such as Autodesk and a bunch of, I think they're working with Adobe as well to optimize the spot market actually. So they have a technology, patented technology. So you can move your workload because of their Zen Blanket technology. You can seamlessly move your workload across different spot markets, from Azure to Amazon seamlessly. And so they're actually doing pretty good at their company as a business.
That's wonderful.
Yeah, I think they recently we did the pilot project with them on the Zen Blanket technology, and they did another pilot with Adobe, I believe. And recently they got funded by
No, Adobe. I think they're Autodesk. I think they're talking to Adobe.
Autodesk. Yeah, I forgot which
Autodesk,
one, but I saw that in LinkedIn newsflash that they got they secured the first round of funding for their work. So that definitely means the technology holds water. So we could definitely use their input and guidance on how to shape Centaurus from the compute side of things as we go forward.
Very cool. Any other team members who can join from his team, Deepak, to continue to support?
From Exotanium?
Yeah.
So they're professors. They all connect. So we can, but we don't want to kind of there are too many people in the advisory board. So
not advisory board. I'm just asking, like, from the contribution standpoint.
Contribution, yeah, we can talk about it.
Have that discussion with them. That's possible.
Yeah.
All
I think this is one of the opportunity. Just like if you think about it, Nikita is there on the call as well. Yeah. So one of the opportunity, the project which I proposed last time, the replacing at CDE with the Ignite. So the technology which we worked on, and which is the technology, the Exotanium, they do business. I think that's a possible synergy, actually. You see, the whole cloud mobility thing, actually. That's pretty powerful technology, actually. So how do you make your workload running in one cloud from, let's say, for example, in Centaurus, in your local data center, and all of a sudden the cloud bursting happens and you end up in AWS or your spot market, and then you end up in Azure seamlessly without even knowing about it. There's a whole machine learning base. So that's a possible synergy as well. So that could be another possible project. So that way, just like GridGain, is gonna work with us to do that contribution. So we can possibly look at that technology as well as we go along.
I see. Cool, good stuff.
Okay, if there are no more questions, Monique, I think Monique is trying to fix some. Yeah, okay. She solved the problem. Now, all TSC members, please have a vote.
Am I a TSC member? Should I vote?
I'm sorry, you can see, but you cannot vote.
Okay, just because I got the pop-up.
Okay.
I have two choices here, well, three.
You can vote, but it won't be counted.
Yeah.
I'll just hit the red X button. Not cause confusion. I obviously think very.
Actually, other projects they have done this. You can vote, but it's a non-binding. So in other words, your vote will not be counted, but it could be considered as a recommendation.
Oh, okay.
There you go.
We definitely will consider your opinion.
Looks like yeah, we just got 6 votes, so just want to make sure all the TS members have already voted.
Yeah, I voted.
Okay. If all of the TS members already voted, I will stop the polling right now.
Okay.
Wow, that's good.
Okay, approved. So yeah, we finished the Deepak's agenda item.
Yeah, we'll plan out, how do we do the kickoff, and we'll plan out. How
we can discuss later on Slack or emails.
But I think Prashant's suggestion is a good suggestion as well. We should have some kind of a blurb, some kind of a paragraph on our website as well as part of Centaurus. What exactly the role is going to be, and what exactly it entails. What are the areas we are interested in, as far as bringing in more advisors, maybe.
Yeah, exactly.
One paragraph, we can do that.
Yeah, to make sure the areas of this advisory boards also benefits kind of match with our interesting area to benefit each other. Right?
Yep.
Okay, great. Vinay, I think the time now is yours.
Okay, thank you, Shawnee. I'm going to share screen and get to the Mesa presentation.
Just 1 minute before Vinay starts, in case some TSC members are not familiar with this, we have 4 SIGs, special interest groups on the Centaurus. They are scalability SIG, edge SIG, networking SIG, and AI SIG. We are having each SIG to update their status and seek advices from our TSC members in each TSC meeting. So it's kind of routine and rotated review. This review is the third one. For this third one, with the next one will be should be the AI SIG. It's kind of just rotated one by one for each TSC meeting. This is just a little background in case some TSC member don't remember this.
Okay, so shall I get started?
Yes, please.
Right. So Mizar, I'm sure many of you are familiar with it already, and if a lot of this is a repeat, please excuse that. Also, I joined the Mizar team a couple of months ago, so I may have very large knowledge gaps in my own understanding of Mizar. I have some idea from the past when I was working with when Sharif was here, and I used to talk to him about it. But I will answer any questions to my best. So with that, what we are going to look at today, what I have on the agenda is to give an overview of Mizar as I see it and as what I have picked up and what we are currently working on, a summary of our collaboration work that we are doing, and we'll take a look at the roadmap that we have planned for the rest of 2021, and there are some resources so that you can easily find information about Mizar and how to get in touch with us regarding communications. So the overview, at the core of Mizar, we rely on the XDP technology in the Linux kernel. This is so eBPF is considered one of the most groundbreaking developments in the Linux kernel in the past whole decade, where it's been used by various companies for different reasons. For example, if there is attack vectors coming in, Facebook, I believe, has done tweaks to the kernel. You can patch the kernel without having to rebuild. You can do it dynamically and then change how the packets are handled to prevent attacks. And for our purpose, we are essentially looking at XDP as a data plane technology to perform the packet overlay functionality that we use in SDN software-defined networks. So at the core, it is just to give a summary comparison of Mizar versus Cilium, which is another implementation of Kubernetes networking and SDN networking in general. They also use eBPF. The difference between us and them is that is the use of is a greater reliance on XDP. So what happens, this is a simple scenario here where we're looking at a pod that's sending out traffic. In Kubernetes, you have pods. Pod sends out traffic, is talking to another pod, is connecting outside the cluster. So in this host, you have the pod that's running in the user space, and typically we use vEth pairs to connect the pod to the host networking stack. And in this case, Cilium would go through TC traffic control hooks. So in that case, what happens is the socket buffer is allocated, SK buffer is allocated in the kernel, and then the processing is done on that. And then it gets sent out to the host NIC using the overlay technology of their choice. Mizar we use Geneve for its extensibility. Geneve has options that you can add. So this makes your overlay technology very extensible. I myself have been using it in a project that I've been working on in the past 3 months. So in this case, what happens, a packet that would come through that's being sent out is intercepted by the XTP hook here. Socket buffer is not even allocated, and that's one of the reasons why where the speed comes from. It's not kernel bypass. It could use the kernel features as it needs, but in this case, we are just going to use the uh, redirect action to send it directly to the transmit API of the host driver. And on the incoming path, there is another XTP hook here, which does some processing. If there is some network policies that say, okay, this packet can come through or this packet needs to be dropped, it's done here. So we don't even hit the escape buff stack. And once it's accepted, it just sent a redirect to the host. So this gives us a lot more speed compared to the Cilium implementation. This is just a very summary. This is not a true apples to apples comparison, but it kind of it's a summary of why we took this approach and what we feel are the advantages of Mizar.
Yeah,
And
it's a very clear summary and comparison. Just to add something, I remember Cilium for some features, it also started using XDP, right? I remember
yes,
in last year. Yeah, so probably if you can add that part, maybe we'll make it more complete. I mean, for Mizar, we build most of our features on XDP, but Cilium they started building I think for the load balancing, external service load balancing using XDP.
For filtering.
Yeah.
They're using it for filtering on ingress. So they on ingress, if they see that the packet is some kind of attack packet, similar to what Facebook might have done from what I read in the blogs.
And also for the service, Kubernetes service, because they are northbound, south-north traffic and east-west traffic. I remember they are using XDP for northwest traffic. All the other parts are still on the socket level eBPF. Yeah, I mean, if we add that part, probably we'll make this a kind of more complete comparison there.
Right. Yeah. Okay. It's good feedback. I think I'll make that change to see without taking focus away from the key differentiation. They use, yes, you're correct. They use XTP here for filtering ingress, and they use TC for policies and bandwidth control, and they use socket filtering as well, socket hooks as well.
Yes, exactly.
Don't remember what for. That was 2 months ago that I read it.
Yeah, that's for the east-west traffic.
Right. Within the.
So they basically break the service handle into two parts. One part is on the socket level, that's for the east-west. The other part is on XTP level for the south and north. I think your comparison is very good. It's just if we add that missing part, it will be more fair, kind of more complete.
Thank you. That's good feedback. Yeah, I'll improve the slide for the future. Just mention the pieces there.
Yeah, just draw a little dot or something put there to show they have a little bit of part there.
Yeah, there is more going on. It's more evolved, and I could say it's more evolved in a different way. We choose to do things in XTP, chained XTP programs, or XTP, pretty much rely on XTP for everything. So, so far, I believe there is some cost savings in that. We do want to get true benchmark head-to-head Cilium versus Mizar. It's one of the things that we're looking at. I'll talk about in the collaboration section of our discussion of our presentation today. So are there any questions regarding this brief slide here? Okay, so I'll move on. The next, okay, so this is looking at the Mizar data plane a little bit more closely. in the previous slide, it was a brief overview. What really is happening when you talk about VE sphere, you can think of it as two pipes, a pipe that goes this way in this direction. Any packet that's sent out that you shove into the TX here pops out at the RX here. Any packet that you shove into the TX here pops out. That's essentially your VE pair. The MESAR our implementation of MESAR uses an eBPF program called Transit Agent, the XTP code that runs at the RX of this VE pair in the host side of the side of the VE pair in the host namespace. And this is where we look at the packet, we determine where it needs to go, and we determine, let's say this is namespace A, this is pod A, and this is pod B. If this was a local pod, if it's on the same host, it's easy. We call the program that sends the transit program that sends it over to the TX. If it is a remote pod, then we determine which host has the pod, which host is which hardware or virtual machine owns the pod, and we encapsulate it in a Geneve packet, and then there is an outer layer, outer IP, which carries the host source address of this NIC and the destination address of the host that is hosting the pod B. And this is done over here, and once it's done, we use XTP redirect to send it to TX. There shouldn't be SKB here, but this is a mistake. So we send this out to TX, and the packet travels to the remote host. Let's say it comes into the ingress of the remote host, then the transit XTP here, another eBPF program that we have, determines what the pod decapsulates it, and then sends it, redirects it to the actual the interface TX that is a destination pod, and this TX would pretty much send the packet, and it pops up in the namespace. Or let's talk about it going from here to this way. So this is an overview of looking at this in a little bit more detail, where we make the changes to get MESAR working. So at the core of in summary, at the core of MESAR, we have the Transit Agent program and the Transit XTP program. There is more functionality to this. I will cover this in the next slide when we look at the scalability aspect of the MESAR architecture. As with most eBPF programs, there is a user space. There's a user space program, a daemon that runs and controls the maps, which determine how these programs behave. So it programs the maps, which is essentially the data that is needed for the program to determine which destination IP it needs to send the packet to. So that essentially is a summary of a little bit a closer look at the detail of how our XTP programs, how we use XTP in MESAR.
Okay, so the left side, the redirect, you just mentioned is wrong. It's also a frame, right?
Yes.
Okay, get it.
On this side, it's frame. Yeah, we redirected the frame. Here also it is frame from what I saw. I'm not sure why it was SKB. I took this from our previous presentation.
I see. So, probably the type. Yeah.
Yeah, it's probably a.
The redirect.
Remember, there was an issue with the generic driver thing. Remember the generic mode and the driver mode thing?
Oh, I see.
Yeah, that's what it is. So it's still SKB. Yeah.
Yeah. I mean, for the generic mode, it's SKB. But for the native mode, it should be the frame, right?
Well, remember there was a problem with the V8 the plugin for the V8, and it doesn't work with the driver mode. So that
one already be solved, right?
Oh, it's already solved, really?
Yeah,
I think so.
From the code, I could see that it's all driver.
But then we should change it then. Yeah. So
this diagram.
Yeah.
This predates, this is last year's diagram. This predates what I have learned in the last 2 months. I just picked it up. Sorry.
That's fine. That's fine.
Okay, so the next part, any more questions on this one? Okay. So the next part is, this is more of how our MESAR's control plane looks like. So in the previous 2 slides, we saw what the data path is, how where the packet manipulations happen, how it gets done. Now, what really makes MESAR, we have these terms, multi-tenancy, and we have large scale. It's built for large scale fast provisioning. What is really making that happen? So when today it's pretty common to have VPC and the concept of networks within the VPC or subnets in the VPC. AWS, GCE, I know they have it. I'm quite certain Azure has similar, if not the same, notions in there. They're organizing the networking for
You're breaking up a
for
bit,
your.
Yeah.
Yeah, I think it's I might need to switch. Okay, I'll be off for a minute.
I think it's okay now. Keep going. Oh, okay. You're already done.
Hello?
Yeah.
Is that better?
Yeah, it's fine.
Yeah,
Yeah.
sorry about that. That other network doesn't. When it starts having problems, it just has problems. So okay. So in the VPC is essentially what we would say as a playground for a single tenant. In this case, in MESAR, it translates to specifically translates to a unique VNI, virtual network identifier, in a Geneve packet, and this is what gives us the isolation. And now we have the concept of bouncers and dividers. What they are, they're just new terms, but if you think about how packets are routed today, how everything is connected, we have switches, we have routers, and we have um, I don't know, AS, the BGP routing uses AS, and we know from it's quite evident that it works quite well, it scales quite well. If you buy a new computer and connect it to your network, the entire world doesn't need to know about it. Just the local switches need to know that, okay, there is a new computer, and and they figure out how to reach it. So this is a loose synonym bouncer. You could think of it as, okay, you have a packet. Let's say this container wants to talk to this virtual machine, and they're in the same network. The container would bounce the packet off this and then send it to the VM, and vice versa. Now, this is a one-hop talk all the time, and we of course do have a mechanism where we can, if this container is communicating with this, what happens here, let's say a new container, this is a new container, it pops up. The only things that you need to do to get this container connected is tell this container, or the host that is hosting this container, what its bouncer IP address is. So that's one entry to the XDP table on the host. This bouncer is running on a different host. So then you go to this bouncer and tell it, okay, you have a new container that belongs to your network, and this is its IP address and MAC address, or this is its host IP address. So it has the host MAC address, so it's gonna, any packets that are going to this from this virtual machine, even before it knows about this, is gonna go to the bouncer. The bouncer is gonna say, yeah, I know how to send it, it's gonna send it this way. And then it also sends a redirect back saying, okay, you want to talk to him directly, talk to this host. So all this is happening in network. You don't have to program the flow tables, or as with OVS, you have flow tables on each of the hosts. You don't have to go and program this host's flow table and this host's flow table to tell them about each other. So that makes MESAR's provisioning O1 operation. if you can imagine that you have a new virtual machine that's come up, and it needs to talk to all these other previously existing serverless container instances, then each of those hosts need to know this is here. That's what OVN does. And so you will see that OVN's provisioning time linearly increases with the number of pods and nodes, whereas Mizar's provisioning is pretty much constant time. So that makes it a great solution for today's cloud. So cloud networking, the reality of today's cloud networking scenarios, where you have serverless, which is quick pods come up, do something, go away, and some pods are short-lived. So it's for those pods as well that this works very well. So you want to provision a new pod. It's a one operation that always, that's always a great thing. And we are, of course, when we started building this, the sheriff took this architecture, kept this architecture in mind, because this works well, scales well. We know, because we're able to sit in different places, different locations, and we're having this meeting. So following the same architecture is a good idea. In terms of how this is all implemented, Kubernetes, we have custom resources in Kubernetes, and there is a operator framework. All these terminology that you see, divider, bouncer, VPC, network, they are all abstracted into custom resources, Kubernetes custom resources. And when these are created, the operator goes to work and executes a certain workflow to go and program the daemons and the transit. In the previous slide, we saw the transit XDP here. It programs the bouncer. One of these is behaving as a bouncer. It goes and programs the bouncer. It goes and programs the daemons. Okay, you have a new pod. So when that new pod is connected, its packets that come out of that are handled correctly. So all this is done in the previous, sorry, I'm jumping slides here. Okay, there we go. So custom resources, we use Kubernetes custom resources and the operators in Kubernetes to manage all this, manage the bouncer, bringing up the bouncers, initializing them and provisioning them. And when new pods come, handling the provisioning of the endpoints for those pods. I've not shown those here, but there are a few more objects, a few more CR custom resource objects that make all these things function. I'll perhaps reserve it for a future meeting to go into details of how control plane works. Maybe one of the folks in our team can present that. But
Vinay, I just have a quick question. Did you verify all the scenarios working like VM container and serverless side by side on a VPC?
We have not verified the VMs with containers, pods. Yes, we have done that.
Okay.
Well, let me restate that. I have not verified it with VMs yet, but in Arctos, we are able to run VMs and containers side by side. And currently, Mizar, there has been some instabilities, and we don't have it fully working for Arctos, but it has worked in the past with Arctos. That's my understanding. Xiaoning, please correct me if I'm mistaken.
Yeah, yes. I remember we probably did a very basic VM and container side by side networking communication test. I don't remember exactly. But from the networking perspective, actually there basically no much difference. We just provide a virtual network device, and then it's a computing site to either mount it to a VM or mount it to a container. Serverless itself is also running a container. So if you look at the external form, they're only containers and VMs, because serverless are usually running as containers. I'm not sure if that's what you are interested in.
No, I'm thinking, while you're talking, I'm
Mm-hmm.
thinking through it basically. Like I'm just imagining a scenario of OpenStack Kubernetes cluster and a serverless cluster running in parallel.
Yeah, it's like this. You have, let's say you have a Kubernetes cluster. It's running on a few bare metal machines. We Actos, because it's enhancement to the to the Kubernetes, we added the VM capability. So on this Actos cluster, when you create a pod, you can specify if this pod is a VM pod or container pod. And then they are running side by side on a same host. For a container pod, it can be a service function as well. This is how it looks like.
So can your persistent database sit on the container pod and you can still communicate from the VM through your application?
Yes.
They are all first-class citizens. They are running side by side, even on the same host.
It's a unified interface. It doesn't matter. It's an endpoint. So endpoint could be a serverless, it could be a VM, or it could be a container, and they can all talk to each other.
Yes.
What's a communication protocol between the two? I mean, just if I want to know, is it like what's exactly like how we are communicating between the two?
Sorry, Vinay, you go.
So if we imagine, let me just take it back one slide here. So this part of the V8 pair, this is in namespace A of a container or a pod. This might very well be inside a VM. So as far as Mizar is concerned, it really doesn't care. So if they are talking between themselves, let's say this is this is your VM instead of pod in namespace A, and this wants to talk to a container or pod in namespace B, it will probably use TCP, HTTP, UDP. We use Geneve overlay to connect these two and encapsulate the packets, and if necessary, if they're on different hosts, and then communicate. Does that answer your question?
Yeah, I think Prashant, your question was overlay network. So we are we are using Geneve, which is even better than VXLAN, but we can always use VXLAN as well. But Geneve is much more better than
Geneve just provides more options. It's very similar to VXLAN.
And how does it get the security context? I mean, for the virtual machine versus the container?
If they belong to the same VNI or the tenant, then they are part of the same They're part of the same VPC.
The reason I'm asking this question because I have an app modernization workload in Microsoft that I'm looking into, where we are using some virtual machines and containers running the databases on the side for a geospatial fencing / application sort of it. Anyway, I will look into it a little bit more and I'll come back to it in the next meeting because it looks like solving a very interesting problem.
Even security standpoint, it shouldn't really matter if it's a VM or it's the same interface. So you get the same security policies that can be applied to your container. It's an endpoint. From Mizar standpoint, it doesn't care. It's an endpoint. It could be a VM or it could be a container.
Yeah, if you are talking about runtime security, I mean computing security.
Yeah, computing security.
Yeah, we are using Kata for containers, so they are isolated from each other.
Oh, okay.
Yeah, so that's a different. That's not a networking. That's more like a compute thing.
Yeah. And on the VPC, when you're creating the whole virtual private scenario, I see the boundaries of the VM and container in the same place while serverless, because I'm new to serverless. I just want to understand that these are like two subdomains altogether, right? In the picture itself. Is this how it works, or it can work in like one Venn diagram?
This is just different applications connected to different networks.
Okay.
What this really shows is that within a VPC, a virtual machine running on this, say, network A can talk to a serverless running on network B, or a container running on the same network A, even if they are connected to different networks. They can communicate by default, which is the Kubernetes model, where everything it's a flat networking space. So this could look like a Kubernetes cluster that is running a VM, running a container, and a serverless instance. And multi-tenancy is where you take this whole circle and replicate them, and there is isolation between them. Of
Well,
course,
I understand the left part because I have worked very closely with OpenShift in Red Hat. So that's like a Red Hat looks like piece of OpenShift Red Hat in that way. But when I look at the serverless, maybe I need to read more. I'll ask something relevant next time.
Sure. Okay. I'm trying to understand what security context means in this case a little bit more. So
from the computing standpoint, when you are communicating between the both the virtual machines and the containers, and if my data is through from the compute standpoint, if I'm trying to access the resources that are running on the container,
right,
under the same VPC, and if I have like already one machine is running more like an Active Directory and another machine running more into the LDAP kind of a scenario. So that is what I was trying to see, that because currently some of the clusters of databases are running on the pod. They spin like tons of images of SQL and other databases, Postgre and MySQL. And then all the virtual machines which are running the applications are on the Microsoft AD side of it.
Right. Okay. Is your concern about, let's say we draw a VPC, another circle here, call it VPC2. Are they completely isolated from seeing any traffic that goes between these two?
Partially.
The answer to that is yes, there is isolation. So if you're connected here, you cannot sniff anything and see what's going on in another VPC. The XTP program just won't send anything towards your way that way.
Got it.
Now, between these two, if there is secure communication that needs to happen, that is that's a construct of the upper layer. We are not securing that. So it's the encryption may need to happen here.
Between the two.
Yeah. Inside the container or the VM.
Got it. Well, I think next time what I will try to bring the use case scenario that you are talking or whatever you are presenting, and how we can sort of address that with the Mizar. And that's why I asked, like, did we try all this scenario on a real time scenario kind of thing? So
okay, yeah, that's going to be very helpful. Thanks, Prashant.
Yeah, that'd be great.
Any more questions?
How many more slides do you have?
Few more. I think this is core of the tech part of it. There is what we're doing, current work. I'll kind of go through this fairly quickly.
That's fine. That's fine. We have like 10 more minutes, and if everybody else is okay, we can run a little over. That's fine. Just want to make sure, yeah, because we probably want to discuss more about what's the current work and the future plan, right?
Yeah. Well, let's get to that. It'll take a few minutes to just go over this. Given the context, I think Mizar, we have had some stability issues with Mizar, and we're working on fixing that. Foo's been working really hard on fixing that, and we're getting pretty close to getting it very functional and usable and easy to use. And then our integration with Arctos, which is currently not working very well, we're working on that as well. And label-based policy, it's one of the projects that we're working for this May 30th release. In a nutshell, this is an improvement, optimization to improve the performance of network policies. What happens is that, let's say you are netpod 1 and you're trying to communicate to netpod 2, and there are policies which says, okay, you are allowed, but somebody else, netpod 3 over here, may not be allowed. Kubernetes has labels on the pods, and here we determine if the pod contains label X, then you allow it. Today, what we have is we check if the pod has label X, we take its IP address, and then we check the IP address. Now, this pod restarts, the IP address has changed, so you need to go and update the policies. The idea is to translate the labels on the pod into a number that is put into the packet. This is where Genevieve Geneve encapsulation plays a big role. So you have the VNI, which is your VPC isolation identifier. Then you have the label, which is a number in the Geneve option. And when the packet comes here, we just have to look at the option and say, okay, does this label match allowed list? And if it does, you let it go. If not, you do a drop. And the next thing that we're working on is the bandwidth. There is a request from that was there for to see if we could do classify traffic that's classify pods as high priority and low priority. What that means is that this pod is considered a high priority pod and it should get more network bandwidth. And there's another pod here, which is a low priority pod that should not get as much network bandwidth. We could do one better where we see traffic. Let's say there is a traffic that's going from a certain port, it's high priority, and a traffic that goes from a different port, we can classify it as low priority. We do that classification determination in the XDP program at the VETH pair when the packet comes out, and determine whether it should be whether it should go in the fast, which is essentially redirect, which we call it the fast path, which is avoiding the escape buff and all those allocations. The other one is to use the rate limited path, and for that we use the algorithm called earliest departure time, which uses the TC traffic control eBPF hook. Traffic control is fairly commonly used. It's been there for a while in Linux, and it's used for rate limiting and packet traffic shaping of packets. The EDT algorithm is essentially it puts a delay between a sequence of packets that belong to the rate limited stream, and that effectively limits how fast there is fair queuing here in the TC infrastructure that ensures that packets are not departing the VM, departing the host until its departure time has been reached, and that ensures a rate limiting of the packets. So this is something that we are going to have in the next milestone, the May end of this month. So we've been working on that. There's some collaboration work that we're also involved in with the University of Washington. We're working on, there is some common interest in looking at how we can do hardware offload for eBPF and XDP hardware offload. They're interested from the perspective of load balancing. We are sharing ideas. And we're also working with the US University of Science Technology in China. They are helping us with hardware, also helping us with Mizar hardware offload functions. They're taken over some pieces of work. They're like adding statistics to our current Mizar infrastructure, reducing the memory footprints. In the previous slides, if we saw, one thing you would notice is you have every VETH pair, you have a transit program, agent program. So if there are 100 pods, you have 100 of these. Can we optimize this and have one common of all of them share one? So that was the idea. So that reduces the footprint of the XDP program that you are in the host. It's not big, but it helps. So that's one of the ideas that we were looking into, and they're looking at doing that. We are looking at doing offload of the bouncers and dividers functionality. We did hit some challenges. I think the biggest challenge that we have encountered with the offload program is that we don't have good support for NICs, hardware offload NICs available in the market right now. The closest we have is from a company called Metronome, and they have certain limitations which are crippling for Mizar. For example, they don't support XTP redirect, and Mizar relies heavily on the XTP redirect construct. So we are trying to see what we can do with the limited functionality that we get from Metronome or other NICs that might be there.
So I recently also read another use case about a cloud provider. They are using Bluefield to offload all their computing, networking, and storage. These agents and the agents, daemons, all these things into the smart NIC, but they're using Bluefield. It looks like NVIDIA has really put a lot of kind of efforts on this Docker and the
Bluefield is the leader, and Netronom is going to go away eventually.
Yeah. I feel like Bluefield and Docker, this thing probably will become like a more mainstream, more comprehensive. And the Netronom is more like focused on specialized in this networking offloading thing.
Right.
And also it's support for eBPF offloading not completely.
Okay.
And I'm wondering if we are using Bluefield, we just run a regular Linux kernel on its ARM core. Can we also run offload XTP there? I mean, if we only look at this commercially available smart NICs to support XTP or eBPF directly, then so far we have only Netronom, right?
Yeah.
But if we are running Linux kernel on the ARM cores on the Bluefield, can we also offload XTP there? I'm not sure. Maybe that's another way of calculating.
But that kind of defeats the whole purpose, though. You don't want to run XTP data plane on ARM. That will slow down actually. So you want to run it on ASIC, basically. Remember we had that big discussion. So I think that gets pretty calm. We can discuss some other time.
Yeah, I just don't know what's the performance difference there. Yeah, we can look at that.
Yeah,
that's another approach. Yeah.
So that's a good point. So that it's worth looking into because remember the talk that UW professor Arvind gave last week, I think. He talked about how they were using this what they call is Flash, pretty much a simple Flash.
JBob.
Did you guys have the meeting last Friday?
Yeah.
Oh, you were not there, Sean.
Yeah, I know. Last Friday afternoon, I didn't.
No. That's the same meeting 2 weeks ago.
2 weeks ago.
Okay, 2 weeks ago. Okay.
Yeah, 2 weeks ago.
Okay, I was there.
Thursday, I believe. So he talked about how they essentially they're hanging off a bunch of flash storage of a PCI, what is logically a PCI root, and it takes away the work that the host would otherwise need to do for simple, storage. So even this having a separate Linux, a low-cost ARM Linux could be useful if the scale becomes massive.
Yeah, first, I don't know if the ARM cores on the Bluefield is maybe they're very powerful. I don't know now. I don't know what's the exact performance level. And second, when we talk about offloading to the smart NIC, it's not only for CPU performance. It's also about isolate the performance interactions among this user customer workloads and our own management workloads. So there will be no kind of intervention.
Yeah. But like AWS has the whole network.
Yes, Nitro. That's the purpose, right? Well, first avoid any performance intervention. They call it
you can provide bare metal to the end customer, basically.
Yeah, they call it cloud tax. Imagine all our agents, daemons, and this thing. They call cloud tax. They want to isolate this tax with the real user custom workloads, and also provide all the resources on the host to customers.
So whole bare metal, yeah, exactly.
Yeah. So I think we can still worthwhile try this offloading everything on Bluefield, but maybe it's more viable for us. Looks like there's a capability limit on the Netronom.
Yes, Netronom, we have to do changes to use what they have, but this could be a potential where we can just take it and then drop it in there, and I think that's a good idea. We'll look into that.
But we can still first finish the kind of middle box scenario on Netronom, right?
Right. Yeah. Thank you. So, and lastly, we have started working with Click to Cloud in India, and the team there is ramping up on and helping out with Mesa Arctos integration and one-click deployment, and we're looking forward to the collaboration with them.
Well, as far as I think, when I see this demo, I think I need to have some senior resources out there. It won't be able to work with this level of depth. I think from Click to Cloud, mostly they could be able to do testing and mostly UI and integration work. But what we are talking about from the Mesa standpoint or Arctos standpoint, it's pretty intense.
Yes.
It's not like people can understand the code base at that complex level.
Yeah,
So
most of this work are kind of state of the art.
yeah. So maybe we need to, I probably will look into it later today to define the use case scenario from testing, massive amount of testing on whatever has been developed and finding the right issues and the one-click deployment scenario. But for development and support, I mean, after going through this meeting, I think it needs a very different caliber.
Mm.
Yeah, so we need to find some really good local strong engineers. I
Strong
mean,
engineers. Because
Yeah.
this,
I think this is what I wanted to kind of highlight that as well. I think
Oh.
Vinay has done a great job in kind of describing the technology. But if you, from a very 30,000, this is one of the biggest contribution we have as part of Centaurus. Because if you want to build a large scale cloud in open source, you cannot build it. The reason being networking becomes a big impediment basically. So if you're going to support millions of endpoints come and go, serverless functions and containers, you cannot build that using Neutron, which typically you would use. Neutron is based on flow table model basically.
Yeah,
So
well, this takes me back like almost 10 years or 9 years when we built XPath on OpenShift network, which is a cross communication between Microsoft, and I could get the glimpse of it already in the today's meeting that how intense it could be. And
so this is like a distributed programming, distributed
yep,
application program. This is
yep,
not a flow table thing, and this is exactly what all the cloud providers do. If you
yeah,
look at Amazon, they don't use OVSs or flow tables and all that because that doesn't scale.
yeah,
So this is one of the biggest value proposition of our platform. If you look at Kubernetes, it doesn't even have its networking, okay?
yeah,
And
yep.
if you look at OpenStack, it has a Neutron, but you cannot build a big large-scale cloud platform because of their networking.
I mean, even if you look at like simple things like memory footprint improvement, that's an intense in a Kubernetes structure or whatever. Like even you're looking at the telemetry collection on a running workload, that itself is an intense thing.
Yeah, so I think this is very profound. Actually, this is a very big contribution from Centaurus standpoint. This whole
It
networking.
is. It
Yeah.
is. It's a
and
big deal.
this piece of work requires very strong developers.
Very strong developers. It's not like, I mean,
Yeah.
it is more of a PhD level applications typically. I used to work with this guy Sergey and Vlad, one from Romania and one from Russia. They used to write like massive amount of code in that area. I remember that. They used to work for me. Now then we sold the company to HP. So they went to HP now. But I get that feeling like good that I attended today's meeting and got through Vinay's overall progress. So that gives us like what we can contribute and what we are capable of. So that's good.
Great.
Okay. Yeah, I think main thing is knowledge of Kubernetes, because Arctos is a fork of Kubernetes, and an understanding of overlay networking, how things work. XGP, I agree. I'm 2 months in, and there's a lot I don't know and learning. I can see that as being there is a learning curve to it, because you can't just you can get just any C developer and have him write XTP programs. You need to know stuff.
Yeah.
So
Well, I think we'll have a different conversation.
okay,
I'll call you and Shawning little bit later in the day
sure.
if you have time, or maybe some other day, and we can go through it like the scope of different areas and define it clearly so that there is a better success path for everyone.
Mm.
Okay.
Yeah. It's a good session because I understand the depth of like where we are going with everything and the scenarios, and we also understand where we can contribute as Click to Cloud and be successful in that.
Right. That
Yeah.
we want to ensure that. Thank you.
Yeah.
So that pretty much covers the. I'm at the last slide here. So what we have, a lot of these are not defined in detail yet. So some of the items that were tossed around, this was 3 months back when I just joined the team, that, okay, we want to have support for multiple interfaces, multiple networks. CNI Gene is one of the projects that was done here at FutureWave. When I just joined, that was done. And we want to see if we can, leverage that. supporting cluster IP, node port. These are Kubernetes concepts. We want to be able to support all of those. Our current CNI implementation, pretty much all of Mizar is written in the control plane part of it is written in Python. We want to slowly start transitioning, at least start with the CNI and transition it towards Golang. That was one of the things that we might work on. And the Zeta features, please don't ask me what it is. I have just gotten a handle of Mizar, but it's a very interesting project that's mainly for bringing Mizar mainstream out for all as a solution that would rival OpenStack, I believe. Deepak, correct me if that's not the right way to describe it.
So I think Zeta is one of the missing. So currently, if you want to build a network functions, the only thing you can do is the stateful function, stateless functions currently, because we don't have a state management capability, and that's what Zeta is all about. So once you have so for example, the NATing, if you want to build a NAT function or a load balancer function, you need some kind of a state basically. So if your one node goes down, you automatically go to another node, so you have the state available. So that's the missing piece we need to build out.
Okay. Right. Okay. Stateful Mizar. Okay. That sounds interesting.
Yeah, stateful Mizar. Yeah, that's what it is, basically. Yeah.
Okay. I'm trying to remember what I know from my dealings with OVS, OVN in this case.
I have to drop out for now. Sorry, I have another meeting coming up.
Okay, thanks.
Okay, thanks. Yeah, we are also wrapping up.
Yeah.
Thank you, guys.
Yeah,
thanks.
Good meeting. Great information.
Okay.
Thank
One
you.
last question before we leave, right? Dr. Shawning, are we looking at like other 4 SIGs people also presenting what is going on in their different areas?
Yes, we have, as I mentioned, we have 4 SIGs. So it's kind of a rotated review. This is the third one.
Okay.
The next one will be the AI SIG.
Okay.
We will present what we are doing.
Remember last time we presented the edge
computing.
Yeah,
that's the second one. Yeah,
Okay.
the first one we presented the scalability SIG.
Got it.
Yeah.
Well,
On I will post a link on the chat window. You can see all the SIGs we have. And let me see. It's
and then all the SIGs have different owners, like different, like Vinay is more on.
yeah, we call it a SIG lead. It's more like leading the technology stuff and coordinating.
Got it.
Yeah, you can join any SIG you are interested in.
No, I'm more keen on like listening to some of the SIGs and see what is going on. And like...
Oh yeah. Here I posted a link here. You can see all the SIGs, the introduction and their weekly meeting and the documents.
Perfect.
Each SIG has their own weekly meeting, and monthly we have a rotated review on the TSC meeting.
Yeah, let's have a call later today if you have time. I mean, I'll float the email, and Deepak, if you want to join, you can join too.
Okay, yeah, sure. Yeah.
All right.
Okay.
All right.
If there are any other questions before we finish the meeting?
That's all. I think it's all good.
Sanil, I saw your chat. It will be really great to have you guys involved in the contribution for that. That would be really great. I saw your chat message.
All right, guys. In another meeting. So,
yeah, Sanil mentioned to me he's in another meeting. He needs to present.
Well, in any case, I think the more external contributors we have, the better it is.
Yeah, this is going to be great if we can get more contribution on the multi-networking. This is going to be a unique addition to Mizar that others don't have.
Okay.
All right.
Thank you. Thank you guys. Thank you for your time. And thank you, Vinay and Deepak, for presenting.
Thanks, everybody. Hey, Sanil, take care. I'll touch base with you later. I hope everything is better in India. He can't talk, I know. So.
Yeah, he's
same. All the best wishes, Sanil. Take care.
Thank you very much.
Okay, bye-bye. Bye-bye, everybody.